My name is Dr. Yeap Ban Har, and I will share a problem with you. And the problem is this. How many 1/3 are there in half? You can think of a story to help you. For example, Spiky has half a cake. How many slices that is this size can Spiky get from half a cake? Or you can pick your own story. The problem today is in half, how many thirds are there? You can use concrete materials like pieces of paper, perhaps squares or rectangles. Let that represent 1. So if this represents 1, can you imagine how half and 1/3 might look like? Or you can use other materials like rectangular pieces to build a model for 1 and use that to think about today's problem. How many 1/3 are there in 1/2? Talk to your friends about that. Remember, when we solve a problem, we try to solve it in more than one way. Hopefully, you can get method 1 and method 2. And perhaps, on clever days, you might even get method 3. I wonder if today is a clever. Also remember, we agree to listen. We do not need to agree. Sometimes, when discussing things with our friends, we may have different opinions, different ideas, different solutions, different answers. That's all right. We agree to listen. We do not need to agree. Let us now try to solve the problem. Method 1. In method 1, we use rectangular pieces to make the model for numbers. The 6 pieces represent 1. Can you see which part of the model shows half? That is right. This is half if the whole thing is 1. How about thirds? If this represents 1, can you see thirds? 2 pieces represent 1/3. Is this 1/3? This is 1/3 if 3 of this make 1. Is it true? 3 of this make 1? So this is 1/3. This is another 1/3. And this is yet another 1/3. There are 3 thirds in 1. Our problem is, in half, how many thirds are there? There's already 1, 1/3, and there is a fraction of 1/3. What fraction of 1/3 is that? That's correct. This is half of 1/3. In other words, in half, there is 1/3 and another half of 1/3. In half, how many thirds? There is 1.5 thirds. we can write the results like this. In half, how many thirds? We have found out that there is 1 and another half thirds, making up half. But usually for fractions, in particular mixed numbers, there's no need to write the addition symbol. We can simply write it like so. 1 and a half. Method 2. Some of us prefer to use equivalent fractions to help us. We can see that half is a bunch of 6. Half is 3/6. This is a 6 because 6 of this make 1. And 1/3 is equal to 2/6. We can write it like this. In 1/2, how many 1/3? It's the same as to say, in 3/6, how many 2/6? Of course, we can write it out in words. In 3/6, how many 2/6? Can we see? In 3, anything, how many 2 of the same things are there? We can use the model to help us. In 3, how many 2's? There's 1 2, and this is half of 2. Of course, 1 is half of 2. In 3, how many 2's? We can see that, isn't it? In 3, there is 1 2 and half of a 2. So in 3/6, how many 2/6? It's like asking ourselves, in 3, how many 2's? There is 1 and a half. Method 3. Some of us think that it is quite easy to think about 1. In 1, how many thirds? It's an easy problem to solve. In 1, how many thirds? Many of us know the answer almost immediately. And if we know this, we can figure out quite easily the original problem, which is in half, how many 1/3? So if in 1, there are 3 1/3s, in half, can you see how many thirds there are? Of course, it's just half as much as what we got before. Does this make sense to you? Our friends who proposed method 3 thinks that this is sensible. If you know how much there is in 1, you will know how much there is in any amount, including half. If in 1, we have that much, in half, we will have half as much. And they think that we can then use this idea to solve any other problem. For example, any other number, how many 1/3, we can figure it out in the same way. If we know how much there is in 1, we can easily figure out how much there is in any amount. So today is a clever day. We have method 1, method 2, and also method 3. I wonder which of this method you prefer. I wonder which of these methods will continue to work in other problems that involve other numbers. Dear colleagues, that is one way to present an anchor task. There are many ways to present anchor tasks, but whatever we do, make sure we provide students with the opportunity to learn whatever they need to learn through a single problem. To paraphrase Paulia, it is better for students to solve one problem in 5 ways than to solve 5 different problems. Provide ample opportunities at exploration before structured learning. That's from Dean's theory. Provide concrete materials. Provide visuals, pictorial representations before they move on to abstraction. That is Bruner's CPA approach. Make sure there's ample opportunities for interaction and conversation. That is based on Vygotsky's theory. Also, Piaget's idea of children using their own natural spoken language to grapple with abstract ideas. Focus on conceptual understanding rather than tricks, formula, procedures. That is Scamm's theory. In a structured discussion, you would expect the struggling learners to be able to come up with at least one method outlined in method 1. For average learners, they should be able to come up with method 1 and method 2. And if they're advanced learners in the class, method 3 and beyond are some possibilities for them to challenge themselves. In this video, we see how we can implement an anchor task and conduct structured discussion.